Hi everyone, welcome back to OOAD Lecturer Series 1.1. So, I am Mr. V. Kovendan, Assistant Professor of the Department CSE in Arasu Engineering College. Today we are going to discuss about the topic structure of the UML, right? So, what is the basic structure of the UML? So, this UML consists of the basic building blocks and the common mechanism and architecture. So, these three are the basic components of a structure of an UML. So, today we are going to discuss about the building blocks. So, what is an building blocks? So, to construct a application, we need the blocks, right? So, and under the building blocks, we have consist of the basics UML modeling elements and a relationship and the diagram. And the second thing is the common mechanism. What are the common mechanism we are going to use to achieve the particular application development or a particular goal? So UML ways to achieve the specific goals. So that is the common mechanism and the architecture. So the view of the system architecture. So it gives the entire process architecture and what are all the inputs and what are the outputs. Based on that input, what is going to be processes inside the structure. So this explains these three common building blocks, a common mechanism and architecture. Then, under the building blocks, there are three major parts are there. One is things. So things can explains that how the elements can be modeled, and the second part is the relationship. So how things are semantically related with each other, and the third part is the diagram. So this diagram will gives the overview visualization of your model, and it shows the collection of things and what system do, that means analysis levels of the diagrams and how it will does. So it will explains the design level of the diagram. So this building blocks of will consist of the things, relationships and the diagrams. So as UML describes the real time system, it is very important to make a conceptual model and then it proceeds gradually. So, the conceptual model of the UML can be mastered by learning the following three major elements. The first thing, as we already discussed, that UML building blocks, and the second thing, rules to connect the building blocks, and the common mechanism of the UML. So in this lecture, in this lecture series, we are going to describe all the UML building blocks. The building blocks of UML can be defined as the three things. One is things, second one is a relationship, and third one is diagram. So under these things, so things are the most important building blocks of UML. So the things can be a structural, or it is a behavioral, or a grouping, or annotational. So structural things can be the structural things of the defined, that static part of the model. So they represents the physical and the conceptual element. uh, some of the following descriptions for the structural things are given. So the structural things are the nouns of the UML modeling. So first one is class. So classes represents the set of object having a similar responsibilities. So mean that the class can be have a set of object. So each and every object inside the classes have the similar responsibilities. So as we know very well about the class, have some objects also. So I'm just giving the description of the class here. So think that it is a class diagram. So class is containing the class name. So okay, under the class name it will be having the attributes. So under that attribute it will be having the operations. So uh, as we discussed, a class have the relevant object with the similar responsibilities. So that is the classes. And the next thing is interfaces. So what is interface? So interface, it defines a set of operations which specify the responsibility of a class. So it will be going to act as a interface between the operation which is specified in a class, right? Next, collaboration. So this collaboration defines the interaction between the elements, right? So it will be act as a intermediate or interaction between the elements. Okay. And next, use case. So this use case represents a set of actions that performed by a system for a specific goal. So we here use case, we know that we are using the use case diagram. So that represents a set of action performed by a system for a specific goal, right? And next is the component. Okay. So that is yeah, your component will describes the physical part of the system. So it will be explaining the physical part which is available on the system, right? And final one is the node. So a node can be defined as a physical element that exists at the runtime. So the node can be executed at the runtime element. Okay. And next we move on to the behavioral things, right? Okay. These behavioral things consist of the dynamic parts of the UML models. The some following are the behavioral things which was given there. So the verb of the UML model. So these behavioral things will be act as the verb all of the UML models. The first one is interaction. So interaction is defined as a behavior that consists of a group of messages that needs to be exchanged among the elements to accomplish a specific task. So interaction mean that the interaction will have some message. So this interaction will have some message. So that message will be transmitted or exchanged from one element to another element to accomplish the specific task. And next one is state changes. So the state machine is useful when the state of an object that itself it is having a life cycle, that is the important thing. So it defines that the sequence of the state of an object goes through in a response to the event. That means events are the external factor for it for the responsible for state changes, right? So when an event will happening, that the state machine will give the external responsibility for the state of the changes. So yeah, application can reaches many stages. So each and every state has to be described in a proper way by using the state machine. And the third thing is the grouping, right? So grouping things can be defined as a mechanism to group elements of a UML model together. There is only one grouping thing available in the method. So that is the package. So this package is used to group the semantical related element. Means that a package is the only one grouping thing that is available for gathering the structural and the behavioral thing. So we know the package diagram. So that will be discussed later in our subject, right? So next, annotation things. So annotational thing can be defined as a mechanism to capture the remarks, the descriptions, and the commands of the UML model elements. So a node will be there. So we can make the explanation of the particular. So what annotation means? Now I am making some note on this page, right? So I'm scribbling something on this the pad, right? So that makes the note, right? So this can be called as the annotation, right? So sticky note or making a note that will be helpful for making the note for the future reference, right? A note is used to render the commands or constraints, etc. of an UML element, right? Next, move on to the relationship, UML relationship. So the UML relationship is another most important building blocks of the UML. It shows how elements are associated with each other, and this association describes that the functionality of an application. So there are some four kinds of relationships are available in the UML relationship. The first thing is dependency, association, generalization, and realization. So these are the four kinds which we are using there, and it used to show and model how two or more things are related, to capturing the meaningful connection between the things, right? So these are all the four types of relationships which helps how other objects models are related with each other, how it was creating the relationship. Let us discuss in detail. The first thing is association. So this association is basically a set of links that connects the element of an UML model. It also describes how many objects are taking part in the relationship. So it describes it giving the connectivity between the elements, and it describes how many objects are taking part in the relationship. So that is the symbol for the association. And the second part is dependency. So this dependency is a relationship between two things in which changes in one element also affects the other one. So once if it is the dependencies, one element is dependent with another element. If we make changes with one, and other one will also get affected. So this is called as the dependency. And the third part is generalization. So this generalization can be defined as a relationship which connects a specialized element with a generalized element. So it is basically described the inheritance concept, that is an inheritance relationship in the world of object. So mean that it will be derived from the base one, and it is have the parental child relationship. So here it comes under the generalization. For simple example, vehicle. So vehicle, under the vehicle, it will be, we will be categorizing a number of elements. Okay, right? And the fourth part is realization. So this realization can be defined as a relationship in which two elements are connected. One element describes some responsibilities which it is not implemented, and the other one implements them. So this relationship exists in the case of sorry, not inheritance, interfaces. So once again I repeat, this realization can be defined as a relationship in which two elements are connected. So if one element describes some responsibility which is not implemented, and the other one implements them, right? So this relationship exists in the case of interfaces, right? Under this generalization, we have two part. One is aggregation and composition. So aggregation, which gives the relationship to the entire part, that is a whole part of the element which is available inside the object. And the composition will express that the comprise, or it contains some only the comprises of the relationship. That means only particular element will be related together with this composition. So that is the difference between the aggregation and the composition, that will be discussed later in our syllabus. Okay. So for a simple example, we are going to discuss how the key steps in the analysis and the design which includes. So there are four key points are there. One is defining the use cases, and the second thing is the defining the domain model, and third thing is define interaction diagram, and fourth one is define the design class diagram. So that is the final thing. So first define the use cases. So use case will explain the overview process of the entire concept. For example, these key ideas are expressed which the dice game, right? A software simulates a player to rolling the twice the dice. If the total is 7, they will win, otherwise they lose the game. So the first module is, so defining the use cases. So we have to analyze the requirements. So what are the necessary things we need to develop this application? So we have to understand the problem first. So to understand this problem, we are going to create the use case scenario of how people use this application. So first thing we have to do is the requirement analysis. After the requirement analysis, we are finding this in the dice game. The use case includes the scenarios. What are the scenario here? Playing a dice game. So player rolls the dice. Yes, that is the concept, and the system needs to give the result based on the condition. So what is the condition here? A player can win if the dice value get the total of 7, otherwise they will lose the game. So this is the definition for the use case for this particular example. For the same example, we are going to define the domain model. So the domain model gives the domain concept, that means how the each and every objects will be related each other. So object oriented analysis here describes the problem in a domain by identifying concept, attributes, association. So concept will gives the entire detail, and the class have the attributes, and by using this relationship model, that is association, we have to relate the objects with each other. So the practical domain model of the dice game is given here. So the player has the player name, can you able to see here? So the player will be there, player having the player name, and the die. So die will be facing the values, it has to reproduce the values, and the die game will includes both the relationship, right? So associated with each objects with multiplicity and so on, so concept that we will discuss, what are the connectivity, one to one, one to many, one, and multiplicity, that will be discussed later in the relationship model also. Okay, so coming to the point, so all these are represent in the domain model. So the concept of the concept, attributes, and the association of the dice game are represented as shown in this figure. So which is the player have the player name, and the player when it rolls the dice will get the value, the given value will be reproduced by the game, right? So and it has to reload. So next defines the interaction diagram. So in this interaction diagram, in object oriented design, the software objects are defined with their responsibilities and collaborations. So for this we are using the interaction diagram called as the sequential diagram. So the sequential diagram is used to represent the collaboration. So mean that the each and every sequence of the action will be taken here, and that was represented in this diagram. So it is the flow of the message between the software object, how it was interacting with the object with one and each other. For example, can you able to see this diagram? Here I am discussing the dice game. So dice 1 and die 2. So obviously this is going to deal with these three object, right? So now the player can start initiated the play, and the first thing he has to roll, right? Once if we rolled the dice, it has to get the face values. So what is the value given by the die? So if it is the roll die 1, it will reproduces the value for the die 1, and if the die 2, and the die 2 will give the value, so we have to get the value. So this is the function of the die 1, and this is the function of the die 2. So in the die example, the player rolls the dice in the real world, but in software design it is illustrated as a die object as shown in the following sequence diagram. So the sequence diagram will give the sequential output of the action performed by the user, right? For the same example, we are going to discuss with the class diagram. So in that interaction diagram, that is in the previous sequence diagram, the sequential diagram, the dynamic view of the collaboration object has been shown there, right? So the static view of the class can be shown with this class diagram. So this is our class diagram. So in this example, the class diagram for the above sequential will for the dice game has been shown here. Here dice game has play the method. So dice has the role, and it has the functions. So that function will be written back and it will be executes. So by using the function called get face value, that is the method of the function, right? For example, take the dice game. So the dice game is the class name, and the class have the attribute of die 1 and die 2, and it has the operation of play. First initially the player has to roll the die. So that is the class. In the class diagram we have described by using the class name, the attributes, So these are all the attributes, and this is the operation. So that is a one to many. So we have created the interfaces. So the die has to give the reproduce the value. So the die will be faces some value, and it will be given, this die is the class name, and face value integer, that will be the attribute, and get face value is the operation or a role. So this is the description of the class diagram for the particular die game. So these are the four key steps in the analyzing of the and the designing of the use case UML module. As we discussed, the key steps in analysis and design includes how it defines the use cases, and defining the domain model, and define the interaction diagram, and how it defines the designing the class diagram. So class diagram will give the entire output of your, it will be taking the whole responsible of the whole heart of the development of an application, so which gives the clear cut description and the connectivity between the object to object. So the blueprint of the object is instead of the class, right? We already know that. So but only by with the help of the class diagram we can get our codes, right? So all this diagram will be discussed later in our next video series. So next we will be discussing with the unified process in the other lecture. Thank you. If you have any doubt, you can ask with me now, or post your questions under the chat window, so that and send your email id, so that I can able to clear your doubts. Okay, thank you.